Let's discuss LeetCode problem number 958. Check completeness of a binary tree. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. Basically, you have to given a binary tree. You need to check whether it is complete or not. In a complete, the definition goes like this. In a complete binary tree, every level except the last one is completely filled and all nodes in the last level are as far left as possible. It can have between 1 to 2 to the power of h, that's the max possible, inclusive at the last level h. So now this is a complete binary tree because if that 6 is to the right, then it is not a complete binary tree, because you see 4 5 and then the left node and the right node, because it has to be as far left as possible. So this one is a binary tree because 6 is on the left node. And let us look at one more definition. So this is exactly the same. Actually, instead of 6 it is 7. I was discussing before. So this is not because the left node, this becomes a null, and then you have a non-null node. So in terms of the solution, let's take a look at the solution. I think so what it boils down to is, if you do breadth first search, the moment you encounter a null node, you cannot see another non-null node. So that is the trick in order to check whether a tree is complete or not. So that's why I call it as null and then non-null pattern. So if you see that, then it is not complete. So that's the pattern you are looking for. So otherwise it's a plain vanilla breadth first search. So you have a queue and then you push the root, and here the end is basically you are marking it as a null or not. So while queue is not empty, you pop the node from the queue, and then if it is null, then you mark it as first null is allowed, because there may not be, all the additional nodes could be null, so you mark it as null. Else then once it is not null, if you have seen the null, then it is not a complete binary tree. Otherwise you push the node dot left and then node dot right, and at the end of it, if it didn't return false from here, you return true, saying that the binary tree is complete. Let us look at some examples. So in this case, processing breadth first search, so you go level by level. So 1 and then 2 3 you add to the queue, and then you add 4 5 and then 6 to the queue. So and then at the end of it, like encounter a null node. Basically here at 4 and 5 you encounter a null nodes. So after that, once you keep going 4 5 null nodes, you percolate up and everything, and finally you will end up with no non-null node. So that's why you return 1 in this case. So in this case, at this 2 level itself, you push a null node and then you pick up the 6 node, and that's where it returns false. So encountered a null node, expecting no more null nodes, encountered a null node, no more null nodes. These are the right to the right of 2, and then to the right to the left of 3, and afterwards you encounter a 6, which is null node, so it is not a complete tree. Comment below if you have any questions. Otherwise, I will see you in the next video.